Good afternoon, students. In last lecture we are studied rules to assign oxidation number, then what is meant by oxidation number, what is meant by oxidizing agent and reducing agent. We know that oxidizing agents are the substances which causes oxidation of another species and itself get reduced. Similarly, reducing agent, these are the species which causes reduction of another species and itself get oxidized. Then rules to assign oxidation number, we know that alkali metal shows +1 oxidation state, alkaline earth metal shows +2 oxidation state in their compounds. Then elements in native or free state shows 0 oxidation state. Oxidation state of monoatomic ion is equal to its net charge. Then oxidation state of oxygen is always -2 except in peroxide it is -1 and in superoxide it is -1/2. Oxidation state of hydrogen is +1 or -1 depending on it is attached to metal or non-metal. If hydrogen is attached to non-metal then it exhibit +1 oxidation state. If hydrogen is attached to metal then it exhibit -1 oxidation state. Oxidation state of halogen is -1. All halogens shows -1 oxidation state. In addition to this, chlorine, bromine, iodine, when bonded to oxygen it shows +1 oxidation state. Then algebraic sum of oxidation state of all atoms in a neutral molecule is equal to 0 and algebraic sum of oxidation state of all atoms in polyatomic ion is equal to its net charge. These are the some rules to assign oxidation state. Now question is assign oxidation number of the underlying atoms in each of the following species. First example, in first example we have to calculate oxidation state of sulfur. SO3 -2. In this we have to calculate oxidation state of sulfur. Oxidation state of sulfur, we know that it is polyatomic ion, therefore algebraic sum of oxidation state of all atoms is equal to its charge. What is the charge is -2, therefore oxidation state of sulfur plus, we know that oxygen exhibit -2 oxidation state generally except in peroxide it shows -1 oxidation state. Therefore this is the, it is not peroxide, therefore oxygen shows -2 oxidation state. Here 3 atoms of oxygen, therefore 3 multiplied by oxidation state of oxygen is equal to -2. Because it is polyatomic ion, algebraic sum of oxidation state of all atoms is equal to its charge. Oxidation state of sulfur plus 3 into oxidation state of oxygen is -2 is equal to -2. Oxidation state of sulfur plus 3 multiplied by 2 is equal to -6. -6 is equal to -2. Therefore oxidation state of sulfur is equal to -2 plus 6, that is equal to +4. This is the oxidation state of sulfur in first example. Then in second example, BrO3 minus. In this we have to calculate oxidation state of bromine. We know that halogens, bromine is the halogen, that is group 17 element, it shows -1 oxidation state. In addition to these, bromine, chlorine, iodine, when attached to oxygen then it shows positive oxidation state. Here bromine is attached to oxygen, therefore we have to calculate oxidation state of bromine. Oxidation state of bromine plus 3 multiplied by oxidation state of oxygen It is also polyatomic ion, therefore algebraic sum of oxidation state of all atoms is equal to its charge. Charge is -1. Then substituting oxidation state of bromine plus 3 multiplied by oxidation state of oxygen is -2 is equal to -1. Oxidation state of bromine 3 multiplied by 2 is equal to -6 is equal to -1, and oxidation state of bromine is equal to -1 plus 6 is equal to +5. This is the oxidation state of bromine that is, it is positive because it attached to oxygen. Even though it is halogen, it shows positive oxidation state because it is attached to oxygen. Then in third example, ClO4 minus. In this example, we have to calculate oxidation state of chlorine. Here also chlorine is attached to oxygen. Therefore, we know that according to rules, if chlorine, bromine, iodine is attached to oxygen, then it shows positive oxidation state. Chlorine, oxidation state of chlorine plus 4 multiplied by oxidation state of oxygen is equal to, it is polyatomic ion, therefore algebraic sum of oxidation state of all atoms is equal to its charge, that is -1. Oxidation state of chlorine plus 4 multiplied by -2 because oxygen shows -2 oxidation state, -1. Oxidation state of chlorine 4 multiplied by 2 -8 is equal to -1. Therefore, oxidation state of chlorine is equal to -1 plus 8 is equal to +7. In both example, bromine and chlorine is attached to oxygen, therefore it shows positive oxidation state. Then fourth example. In fourth example, we have to calculate oxidation state of nitrogen in ammonium ion, NH4 plus. We know that here nitrogen is attached to hydrogen. We know that oxidation state of hydrogen is either +1 or -1. When hydrogen is attached to non-metal, then it shows +1 oxidation state. When it is attached to metal, then it shows -1 oxidation state. Here hydrogen is attached to nitrogen, which is non-metal. Therefore hydrogen shows +1 oxidation state. Oxidation state of nitrogen plus, here 4 hydrogen, therefore 4 multiplied by oxidation state of hydrogen is equal to what? It is polyatomic ion, polyatomic cation, therefore algebraic sum of oxidation state of all atoms is equal to its charge, that is +1. Oxidation state of nitrogen plus 4 multiplied by 1 is equal to +1. Oxidation state of nitrogen plus 4 is equal to 1. Oxidation state of nitrogen is equal to 1 minus 4 is equal to -3. Oxidation state of nitrogen is -3. Then in fifth example, here also oxidation state of nitrogen is to be calculated. NO3 minus oxidation state of nitrogen. Here also nitrogen oxidation state we have to calculate. Nitrogen is attached to oxygen. We know that oxygen shows -2 oxidation state generally. Oxidation state of nitrogen plus 3 multiplied by oxidation state of oxygen is equal to -1. Oxidation state of nitrogen plus 3 multiplied by oxidation state of oxygen is -2 is equal to -1. Oxidation state of nitrogen 3 multiplied by minus 2 is equal to minus 6 is equal to minus 1. Oxidation state of nitrogen is equal to minus 1 plus 6, that is plus 5. This is the oxidation state of nitrogen in NO3 minus species. Then next example, N2O5, dinitrogen pentoxide. Sixth example, here also oxidation state of nitrogen is to be calculated. Here 2 nitrogen are present, therefore 2 multiplied by oxidation state of nitrogen. 2 multiplied by oxidation state of nitrogen plus 5 oxygen, therefore 5 multiplied by oxidation state of oxygen is equal to what? It is not cation or not anion, it is not ionic species, therefore according to rule, algebraic sum of oxidation state of all atoms in a neutral molecule, it is neutral molecule, is equal to 0. 2 multiplied by oxidation state of nitrogen plus 5 multiplied by oxidation state of oxygen is minus 2 is equal to 0. 2 multiplied by oxidation state of nitrogen minus 10, 5 multiplied by minus 2 is equal to 10 is equal to 0. Therefore 2 multiplied by oxidation state of nitrogen is equal to minus 10 if at opposite side is equal to plus 10, and oxidation state of nitrogen is equal to 10 divided by 2, that is plus 5. This is the oxidation state of nitrogen in this species. Then next example, in next example, oxidation state of phosphorus we have to calculate. It is calcium phosphate. Seventh example, calcium phosphate. Here we have to calculate oxidation state of phosphorus. We know that calcium is which metal? Alkali metal or alkaline earth metal. We know that alkali metal exhibit +1 oxidation state and alkaline earth metal exhibit +2 oxidation state in all their compounds. Therefore calcium is the group second element, that is alkaline earth metal, therefore it exhibit +2 oxidation state. 3 multiplied by oxidation state of calcium plus this 2 multiplied by oxidation state of phosphorus plus 4 multiplied by oxidation state of oxygen okay. We know that oxidation state of calcium is +2, 3 multiplied by 2 because it is alkaline earth metal, plus 2 multiplied by oxidation state of phosphorus is we have to calculate, plus we know that oxygen shows -2 oxidation state, therefore 4 multiplied by -2 bracket complete. Then 3 multiplied by 2, 6 plus 2 oxidation state of phosphorus, 4 multiplied by -2 is equal to -8. 6 plus 2 into oxidation state of phosphorus and -8 multiplied by 2 is equal to -16. Then we have to calculate this. Here it is not polyatomic ionic species, it is a neutral molecule, therefore is equal to 0. Algebraic sum of oxidation states of all atoms in a neutral molecule is equal to 0, Therefore 2 into oxidation state of phosphorus is equal to minus 16 plus 6 is equal to minus 10, and by at opposite side it minus 10 is equal to plus 10. Therefore, oxidation state of phosphorus is equal to 10 divided by 2, that is plus 5. This is oxidation state of phosphorus in calcium phosphate, plus 5. The next example, 8th example, potassium dichromate. K2Cr2O7 means potassium dichromate. Here we have to calculate oxidation state of chromium. K2Cr2O7, potassium dichromate. In this example, potassium, we know that it is alkali metal, and according to rule, alkali metal exhibit +1 oxidation state in all their compounds. Therefore, potassium exhibit +1 oxidation state. Here 2 potassium, therefore 2 multiplied by oxidation state of potassium plus 2 multiplied by oxidation state of chromium plus 7 multiplied by oxidation state of oxygen. And we know that it has no charge, therefore it is neutral molecule, and algebraic sum of oxidation state of all atoms in a neutral molecule is equal to 0. Oxidation state of potassium is +1, 2 multiplied by 1 plus 2 into oxidation state of chromium plus 7 into oxidation state of oxygen is -2 is equal to 0. 2 multiplied by 1, 2 plus 2 into oxidation state of chromium plus 7 multiplied by 2, that is -14 is equal to 0. -14 plus 2, 2 into oxidation state of chromium, -40 plus 2 is equal to -12 is equal to 0. And 2 into oxidation state of chromium is equal to this -12 on right hand side, it is +12. Therefore, oxidation state of chromium is equal to 12 divided by 2, that is +6. This is the oxidation state of chromium. The next example, K2C2O4, potassium oxalate. K2C2O4, 9th example, K2C2O4. In this example, we have to calculate oxidation state of carbon. Here also, potassium is present. We know that potassium is alkali metal, it shows +1 oxidation state in all their compounds. Therefore, 2 multiplied by oxidation state of potassium plus, here also 2 carbons, therefore 2 multiplied by oxidation state of carbon plus 4 oxygen, therefore 4 multiplied by oxidation state of oxygen. And it is neutral molecule, therefore algebraic sum of oxidation states of all atoms is equal to 0. 2 multiplied by oxidation state of potassium is +1 plus 2 into oxidation state of carbon plus 4 into oxidation state of oxygen -2 is equal to 0. 2 multiplied by 1, 2 plus 2 into oxidation state of carbon, 4 multiplied by -2 is equal to -8 is equal to 0. -8 plus 2, 2 into oxidation state of carbon is equal, oxidation state of carbon, this -8 and plus 2 -6 is equal to 0. 2 into oxidation state of carbon is equal to +6, and oxidation state of carbon is equal to 6/2, that is +3. Then in next example, that is 10th example, phosphorus acid H3PO4. In this example, we have to calculate oxidation state of phosphorus. 10th example, we know that hydrogen exhibit either +1 or -1 oxidation state depending on it is bonded to metal or non-metal. When it is bonded to non-metal, then it shows +1 oxidation state, and when it is attached to metal, then it shows -1 oxidation state. Here hydrogen is attached to phosphorus, which is non-metal, therefore hydrogen exhibit +1 oxidation state. 3 multiplied by oxidation state of hydrogen plus oxidation state of phosphorus plus 4 multiplied by oxidation state of oxygen. It is neutral molecule, therefore algebraic sum of oxidation states of all atoms in a neutral molecule is equal to 0. Hydrogen +1 plus oxidation state of phosphorus plus 4 into -2 oxidation state of oxygen. Then 3 plus oxidation state of phosphorus, 4 multiplied by -2 is equal to -8 is equal to 0, and oxidation state of phosphorus -8 plus 3 -5 is equal to 0, and oxidation state of phosphorus is equal to +5. And in last example, 11th example, chromium tetrahydroxyl ion, in which we have to calculate oxidation state of chromium. Oxidation state of chromium plus this 4 multiplied by oxidation state of oxygen plus oxidation state of hydrogen, and it is polyatomic ion because it has minus charge, therefore algebraic sum of oxidation states of all atoms in a polyatomic ion is equal to its charge, that is -1. Oxidation state of chromium plus 4 multiplied by oxidation state of oxygen -2 plus oxidation state of hydrogen. We know that hydrogen is attached to oxygen, which is non-metal, therefore +1 is equal to -1. Oxidation state of chromium plus -2 plus 1 -1 multiplied by 4, that is -4. -4 is equal to -1, and oxidation state of chromium is equal to -1 plus 4, that is +3. This is the oxidation state of chromium. In this way, we can calculate oxidation state of any atom by using this rule.